This video contains sample clips from the course Solving Simple Equations, Part 1. We look for more numbers. We go to the number 2, and we try that number, replacing x by the value 2, to see again if we have a true statement. Using our facts of numbers, 2 times 2 is 4, plus 3 is 7. That is not equal to 9. We have a statement here, but again, it is a false statement. We are interested in finding the number that will make it a true statement. Trying our next number, we try the number 3. When we replace x by the value 3, checking with our facts of numbers, 2 times 3 is 6, plus 3 is equal to 9. 9 is equal to 9 is a true statement. We are going to learn to find the numbers that will make an open statement a statement.
Nicely done. We are going to learn to find the numbers that will make an open statement a true statement.
The process of finding the number that will make an open equality statement a true statement is called solving the equation. The number that makes the statement a true statement is called the solution. This is an example of the solution of an equation. We start with the equation in its most complex form. We use our rules to simplify that equation and make it simpler. We use our rules again to make it even simpler in form. And finally, in this example, in the next step, we make our equation into its simplest form. Our first basic pattern will use the important addition property of equality. We're going to look at our first basic pattern for to add the triangle expression. And remember, our addition property of equality says that we must add the same expression to the right-hand side of the equation. If we are at this step in the solution pattern, then the next step in the solution process is which of the following?
Good work. The next step in the solution process is answer B.
So our next step is to replace x plus 0 with x, and we rewrite the rest of the equation. Let's look at a specific example. We have x minus 3 equals 5. It makes sense if 3 is being subtracted off from x that we should add 3 on to this expression in order to start to make it talk about x all alone. At this point, we recognize 0 is the additive identity, and we use that property that 0 plus x will be x. So we are going to replace x plus 0 with x. In the last example, we showed in great detail how we solve the equation x minus 3 equals 5. We normally do not show or explain as much detail in the solution of our equations. We have actually skipped a number of steps using our rules to justify how we got to this point. But we often do not show simple steps that we frequently use in order to save time and space. And in this case, we are not showing the steps using the definition of subtraction the additive inverse, and the additive identity. In this section, we're going to see how we solve simple equations using the subtraction property of equality. Again, because 3 is being added on to x, it makes sense that to make this speak about x all alone, we should subtract 3 off. So we're going to rewrite this equation in the following way. We take the left-hand side and we're going to subtract 3 from that side in order to start to get x all alone. In this example, to save time, we have not shown the steps demonstrating the definition of subtraction, the additive inverse, and the additive identity. We have not shown these steps, but it's important to remember that we still have used them. Solving simple equations, Part 1.